Hey everyone, so let's take a look at transformations of logarithmic functions. Similar to exponential functions, except this time I have a log. Alright, so let's go over it. So here's our parent function. Alright, our parent function for logarithms is f of x is equal to log base b of x. Alright, we have this. But a transformed function, so a transformed one, it takes on the form of f of x equal to a times log base b of x minus h plus k. Right? Very similar to the exponential function. So if you saw the exponential functions, transformations of exponential functions video, alright, then this might look a little bit repetitive, but let's go ahead and take a look at it. So first things first, we'll start with A. Alright, A discusses the orientation A describes our orientation and shape. So if A is less than 0, this is reflected, let's write it on the other side. So this one is reflected about the x-axis. Okay. Then if the absolute value of A is greater than 1, then we have a vertical stretch happening. Right? And if A is in between, the absolute value of A is in between 0 and 1, then this is a vertical compression. So vertical stretch, you can think of it as like a rubber band. You're like pushing it away. Compression, you're like pushing it into each other, pushing it together. Okay. So this was A. Let's go ahead and color code this just for like fun. Okay, so here's our A. Next we have, alright, B, we talked about that in the parent functions, what happens. Right, let's talk about, so x is the value you input and then h. So now let's look at h. So h, think of it as horizontal translation, alright, which is exactly what it is. So h is the horizontal movement. So any horizontal shift that occurs. So if h is a positive number, then you move h units right. Then now let's look at, right, if h is a negative number, then you would take the absolute value of that and you would move the absolute value of h units to the left. Okay. And then finally, let's look at k. Right? K is also pretty notorious. We've seen it in parabolic functions like quadratics and even in linear equations. This is a vertical shift, and it also applies here. So it's also the vertical shift for a log function as well. The vertical shift, so if your k is positive, then you move k units up. If your k is negative, you would move k units down. Alright, and I hope this helped bring some light to you on the transformations of log functions.